In live events and entertainment, a model is not just geometry, it is information. Every truss segment, fixture, scaffold part, and stage deck carries data about type, length, patch, and height. Data visualization in Vectorworks turns that information into color, line weight, and graphics, so issues stand out and decisions happen faster. Data visualization is a way to restyle objects based on their data without changing the objects themselves. You define which objects you want to evaluate and which data field to look at, and Vectorworks automatically adjusts their appearance so differences are easy to read visually. Because it acts like a visual filter, data visualization can be used in design layers, in viewports, and in other documentation contexts, so the same model can answer different questions at different stages of the process. One example is truss length. Truss systems can look repetitive, but the individual lengths matter for engineering, inventory, transport, and assembly. To make a data visualization, at the top of the view bar, go to the Visualization section. Select New Data Visualization. You now need to define what the object criteria of the visualization will be. Once you've done that, you will need to set the display criteria. This is the heart of the data visualization. For this truss length, I'm using objects using record, truss record, and length. You can see that there are a lot of different ways to parse the data. I'm going to select auto color, and now I'm done. With data visualization, truss objects can be color-coded by length, so different sections stand out immediately in both plan and 3D views. Instead of reading through object data one piece at a time, the rig itself becomes a graphic check of where lengths match, where they do not, and whether the system is using all the pieces you would expect. Another useful example is fixture type. A lighting plot may include multiple fixture families that share similar geometry or sit close together in the rig. Data visualization can color lighting devices by instrument type or another device parameter, making it easier to read the distribution of different types of lighting instruments. This is especially helpful when reviewing balance across positions, checking visual hierarchy in the rig, or explaining the drawing to collaborators who may not read simple variations as quickly as the lighting designer would. A good tip for fixture types is to check Retain Original Fill and select Override Background Color. If you don't have this selected, the movement circles will appear filled in the same color as your lights. Selecting this will keep the movement circles of your lights clear. The choice is up to you. Data visualization is also extremely useful for error checking, especially for patched and unpatched devices. Instead of relying only on worksheets or the object info palette, a user can visualize patch status directly in the drawing by coloring devices according to whether they have complete addressing information. Fully patched fixtures can display one way, and unpatched fixtures a different way. That turns the drawing into a fast quality control view, where missing information becomes obvious before paperwork leaves the office or the plot reaches the venue. In this case, I'm using the by range to look for DMX addresses that are set to 0. If they are red, they are unpatched. You can see the visualization update as the data changes. Scaffolding parts are another strong use case. Scaffold systems often reuse similar objects many times over, which can make it hard to distinguish one part type from another. By visualizing scaffold elements based on part type, length, or another relevant field, drawings become easier to read and easier to verify. This can support both coordination and communication, because the visual differences reinforce how the scaffold system is being assembled and documented. When you are on a sheet layer with a viewport, you can select which data visualization you want to display. If you then select Create Data Visualization Legend, this will create a legend in your annotation space. You can double-click on the legend to edit it. Now you have a handy key to your data visualization right on the sheets in your documentation. Stage decks are also well-suited to data viz. In entertainment design, relative height matters for sightlines, accessibility, staging transitions, and performer movement. Data visualization can color code decks by their height, or another staging-related field, so level changes are immediately legible in model space and in viewports prepared for documentation. For entertainment professionals who already have the data in their models, data visualization is one of the fastest ways to make that data useful.